If I have seen further than others, it is by standing upon the shoulders of giants. And Tom Rossby definitely is one of those giants. Throughout this cruise, his enthusiasm has been infectious. He's been so generous with his time to answer questions that any of us might have, or to share stories of his past adventures on oceanographic research vessels. It's been a pleasure to get to meet Tom this week and work alongside him. So Dr. Rossby and his team, including Dr. Fischer, also from the University of Rhode Island, he's an electrical engineer, they are working together to create a fish tag, a small device that would be attached to fish, so researchers could track their movement in areas and also assess some of the parameters of the water in which those fish are swimming. And there's a picture of the chip as Dr. Fischer was explaining to me how that works. So they are doing a series of tests during this cruise, and in the video that is streaming now, you can see the deployment of a device that they're using to test their fish tags. And there are 3 parts to this sound source that's being deployed in this video. There's the high flyer, which was that first thing that came up the back, and now you see Oscar lowering a series of floats that are attached to that tether, and those are to provide the positive buoyancy to keep the sound source suspended in the water column. And so shortly here you will see the A-frame move out to lift the sound source itself, which is really just a big metal cylinder, a really big heavy metal cylinder. And inside that metal cylinder is a speaker of sorts that is tuned to match the natural frequency of that big cylinder. So by matching the natural frequency of the cylinder, the sound gets vastly amplified, and we're going to see shortly a really great demonstration from Dr. Tom about how that works. Okay, so they are lifting the cylinder, and you do see a smaller cylinder attached to it, and encased in that are some computers and control components that send the signal to the speaker at various times.
Hold that, John.
So Dwight and Oscar are putting the cylinder in position. Captain Sanders, I believe, is operating the A-frame in this operation. There is a release that Oscar will be activating momentarily here to release the cable from the cylinder. It will remain attached to the tether. There it goes, and it starts to sink, and it will sink down into the water column and be suspended there and held in place by the buoys. So once that was deployed, we then made way for about 10 kilometers, and they took these devices that you see here. They have 4 listening devices that were tethered to a rope and simply lowered over the side once we were in that 10-kilometer position away from the beacon. And we listened for an hour, and in that 1-hour period of time there would have been 3 tones emitted by the beacon, and so they listened for them. They had a second device that they lowered over the side to listen for the beacon, and this is a hydrophone seen here. So after 1 hour of listening and recording data, they retrieved the listening devices from the side of the ship and opened them up to get the chip out that's inside there and transfer the data from that chip to the computer so they could analyze the data and see if the sound was arriving and the signal was being received by these listening devices when it should have been based on our distance from the sound source. And what they found initially last night in their data was at this 10 kilometer mark from the sound source, they were not receiving a signal that they expected. So they repacked the listening devices, and we made way back towards the sound beacon and took a series of measurements again for an hour, just over an hour. This time only 1 kilometer away from the sound source. There was concern that maybe the beacon wasn't functioning as it should have been. And so again, then they hauled those lines back up on ship, retrieved the listening devices, opened them up, transferred the data, and analyzed it. And they found that they were getting a sound signal. It just wasn't quite as loud as expected. So the decision was made by the team to return to the sound source, and shortly after daybreak, once the crew had breakfast, we assembled on the deck and assisted with the retrieval of the sound source. And so a hook was tossed over the side to grab the line that was connected from the high flyer to the floats, and then as the ship very slowly made way past the high flyer, it was brought around to the fantail and hoisted up on deck, and that's fairly lightweight. You can see that Dwight is moving it all by himself there, moving it safely out of the way, and Oscar is bringing the line in. The floats are soon to follow here, and those are fairly heavy, so you see he's going to, once he gets those on board, he's going to clip into that with one of those winch lines. And when we're pulling something like that up on board, we've got to be careful that nobody gets pinched or hurt or knocked over by something that's swinging. And so you'll see that they very quickly get those lines secured, so as the sea is kind of gently rolling here, nothing swings by and injures anyone. It's really fun to watch these guys work together as a team, because they are a great team and they communicate really well. And Oscar is a really great boatman. So there you can see the floats coming on in behind. I'm actually going to speed up this playback for you just to save a little bit of time here. So here come the first string of floats. They pull those in, and then the next string of floats coming up with the winch. And you'll see John sneak in here and start to try and secure these so they don't roll around. These ships can be dangerous places when things like this are on deck and not secured. The seas here were very calm, so there wasn't a problem, but the crew is very mindful of these types of hazards and is quick to secure anything that could potentially hurt anyone. So here comes the metal cylinder being pulled up by the capstan. There was a snag there at the pulley on the top of the A-frame where those two lines are joined, but once they got it in the right position, it came on through. And then they quickly worked to get the cylinder stabilized and strapped down on deck. So the team is working together to try and figure out why their sound source was much quieter than expected. And while we were underway to our next work location, Dr. Rossby shared some props that he brought along to help explain the phenomenon he utilizes to generate this sound in this test.
Okay.
Yep.
So this is a little a Bluetooth speaker that you can have with your computer, your laptop. And it's hard to hear, but maybe you can hear it a little bit, that it's making a signal. It's at 130 cycles per second.
Okay. It sounds like the microphone on my phone didn't do a good job at picking up that tone. I did hear a sound, but it was faint.
Okay, now I'm going to turn it off, and I'm going to put it inside this tube. So Daniel's going to hold the tube, and I'm going to stick this in. Why don't you stand over here on the other side? I'm going to stick this in so it's about at half length, and then I'm going to turn it on again.
Wow. Again, the microphone on my phone wasn't picking up that frequency, but it was a very dramatic difference in the volume.
And just are you able to tweak the frequency as you play it?
Yes, I can. Thank you. So I'll turn that on. Now I lower the frequency. It disappears.
And when it doesn't match.
Again, this sound recording doesn't do this demonstration justice because it wasn't picking up the frequency that he was playing. But as he changed the frequency that was being emitted by the speaker inside the tube, the ability of that tube to act as an amplifier went away because the tone coming out of the speaker no longer matched the natural frequency of the tube itself.
Now, if you can wait a second, I'll show you one more thing.
Sure.
We have to turn that off.
So next, Dr. Tom has a great demonstration of pressure waves.
Again. I have permission to use this briefly.
You have to get special permission to do this, where no open flames.
And I'll
should I zoom in?
Turn this on. So I have a little flame. And then I go.
Wow.
Again, the microphone on my phone was not picking up this frequency, but as soon as that tone sounded, the pressure wave coming out of the end of that tube blew out the flame.
And I turn on the sound source.
And so as we continue on this expedition, Dr. Rossby and Dr. Fischer and the rest of their team are working to identify the problems with their design, collect information about it, brainstorm, analyze, develop a solution, implement it in redesign, and then test again, and this cycle continues on and on. For me, it's been an absolute joy to watch this process happen in front of me and watch these giants do their work. This is a creative art and an interpersonal art, and it's so exciting to be a part of it.